Kinematics Worksheet 4 from pre-test question. Question 6. Two markers M1 and M2 are set up a vertical distance h apart. Marker 1, mark 2, and that's the distance between them. A steel ball is released at time 0 from a point at a distance x above M1. The ball reaches M1 at time t1 and reaches M2 at time t2. The acceleration of the ball is constant. Which expression gives the acceleration of the ball? Now, because the answers, they pretty much include T1 and T2, so I'm trying to solve this problem using two sections, one from 0 to T1, and then one from 0 to T2. I'm using the second equation for motion, and my VIT is 0 because my VI is 0. So this is what is left from the second equation. I'm going to replace things here. My D here actually is my X. So this is X is equal half a T1 square. So let me call this first equation 1. Following the same step, I'm going to find the motion equation from time 0 to T2. Okay, so my distance here from 0 to T2 is x plus h. So x plus h is equal half a T2 square. And I'm going to call this equation 2 just for reference. Now I'm going to substitute the equation 1 on equation 2 because I have expression for x. So here is x is half a T1 square plus h is equal half a T2 square. Okay, so now I'm going to stop and go back what the question is asking. Okay, it's asking to find an expression for the acceleration. So I need to rearrange this expression here in terms of the acceleration. So I move this term to the first side of this equation and h to the other side. So this will be negative and this comes negative. I'm going to multiply the whole thing by -1 to change the sign. So this is half a T2 square minus half a T1 square is equal h. So half a and half a is common here, so I will do half a is T2 square minus T1 square is equal h. Okay, now I'm ready to flip everything. I'm going to do a continuation here. Is a is equal to 2 times h over T2 square minus T1 square. So this is the expression and matches with option D. Question 9. A ball is thrown with velocity v and angle theta to the horizontal. The acceleration of free fall is g, and assume that air resistance is negligible. What are the horizontal displacement x and the vertical displacement y after time t? Okay, so I move the this vector, the velocity, and an angle to separately determine the components. So here is the tail of this vector, and from the tip, I'm going to draw my Vy, and this is my Vx. Use sine and cosine, so my Vx is V cosine of theta, and my Vy is V sine of theta. Now I'm going to set up two independent tables, one for the horizontal motion and another one for the vertical motion. So before I fill this table, let me take a look on the trajectory of this ball. So let's say right here, I will have my horizontal component, and going up, I will have less my vertical component because it's decelerating going up. And here I have, start with VH, and these VI and I, and as goes up, the vertical components is decelerating, and the horizontal component remains the same. So right here, my VF going up is 0, is going to stop. So horizontally is the same. Actually, I'm going to change the X and the Y with this horizontal and this vertical to match with my diagram. Okay, so my initial velocity here and my final velocity horizontally is the same. Never gonna change because it's not affected by gravity. So which means Vi here is V cosine of theta. Vf is also V cosine of theta, right here. So this is I, because I calculate the initial for everybody, but my initial horizontally and final, the same is constant. Here, the distance horizontally is the X, and the acceleration here is 0. There is no acceleration horizontally, and time will be time t. The reason is because here says the horizontal displacement x and the vertical displacement y, according to this diagram, is going to happen at the same time t. So this is t. Okay, so vertically, here is V is V sine of theta. The final velocity, it didn't say they actually stop before change direction. So I prefer don't say nothing about the final velocity vertically for the time t. The distance here will be y. The acceleration here, because there is no numerical value, so I'm going to call g, and this time is t. So x and y is going to happen at the same time t. So I just repeat the t here. Okay, horizontally, because the acceleration is 0, so the only formula that I can use is this one. dh is equal vh times th. So my dh here is x, my vh is v cosine of theta, and my time is t. So I'm going to rearrange these because usually we don't multiply, we don't put a value by an angle. So let me rearrange this. So x is vt cosine of theta, and that should be one of the answer. Now, the other answer is related to what is the y. So the y I'm going to find here, right? So now, because I do have acceleration in this case, so I'm using dv is equal vvit plus half a, in this case, gt squared. Going up, the vertical velocity is decelerating. So because it's decelerating, I'm going to change this sign that I did plus with minus. Is this okay? So my dv here is y. My vvi is v sine of theta times t minus half gt squared. So again, I'm going to move this t to the front. So y is vt sine of theta minus half gt squared. And that is the value of y. So the answer that matches with this result, this result is B, right? So B, yes, correct. So B is the answer. So that's the question. Probably there is a mistake with the order, but that's okay. The diagram shows a velocity time graph for a vehicle. The vehicle moving at 4 meters per second begins to accelerate at time equals 0. What is the vehicle's acceleration at time 3 seconds? First, let me describe this graph. This is a velocity time curve, which means that the acceleration is changing over time. In this case, we cannot use motion equations. All motion equations, kinematic equations, they are good when the acceleration is constant. In this case, acceleration is changing, so we have to answer this question just graphically. Okay, so it's asking for the acceleration time 3 seconds right here. So once we identify the time, the next step is to draw a tangent line on that point. So how to draw a tangent line? So here is, you're gonna place the ruler on that point, which is at 3, and that touch the curve, and do not cross the line, and try to make as symmetrical as possible, like we see here, and then you can draw a line. So that's the tangent line. To increase your confidence, if you actually did a very good tangent line, you can also place the ruler by the point right here. Make sure that you are making 90 degrees with the tangent line like this. For example, 90 degrees, and trace like a fine line. It looks good. So it's making 90 degrees with the tangent line. Now we need to draw a right triangle between the tangent line and the curve. You don't want to make too big and stay away from the line. You see, if you get from here, so the curve is right here, so it's kind of off. So try to get as close as possible as long as we form a triangle. So here is a good one, and also this is a good one. So I'm going to shade this with like a yellow, and then we can look at the triangle a little bit better. We need to identify all the points of this triangle. So here we have 4 and 4, which is good. Here we have this value right here that is not very defined. Let's see, right here, and right Okay, so the acceleration of this velocity time graph at this point is the slope right here. So we need to calculate the slope. The acceleration of a velocity time graph is equal to slope. So slope is rise over run. And that for the rise, I'm going to round here 7 minus 4. And for the run, 4 minus 1.5, kind of between 1 and 2, approximately. Okay, so this time I got 1.2 meters per second square. And when I look at the options, this is the closest one. So that will be my pick. Now in class, this is the graph that I did in classroom. And the values that I have here is 7 minus 4. And for the run, 4 minus 1.8. So I kind of, my tangent lie right here. And I got a better number, 1.36. Is a little bit tricky as long as you line up. It's very difficult to line up as long as your answer matches with the closest one, even though those numbers is kind of very similar, kind of, but these will be the option. This is the correct answer. Let's go for this extra problem from kinematics past exam. The diagram shows a laboratory experiment in which a feather falls from rest in a long evacuated vertical tube of length L. The feather takes time t to fall from the top to the bottom of the tube. How far will the feather have fallen from the top of the tube in a time of half of t? To solve the problem, I'm going to find the motion equation from the top to the bottom of this tube. So, because I want to include the length, I want to include the velocity and acceleration and time, so I'm going to use the second equation. So, D is equal VIT plus half AT squared. The problem say the feather fall from rest, so this is eliminated because VI is 0. So then D is equal half AT squared. Now this is with the general label, D, distance, A, and time. Now I'm going to adjust with the variables for this problem. So here my D, the whole distance is L. And then I have half and A, and my T, the total time is uppercase T squared. Because the answer showing decimals, so I'm going ahead and convert this fraction into a decimal. So L is equal 0.5 AT squared. And I'm going to call this one equation 1. Now I'm going to find another motion equation from the top, because I want to take advantage that the initial velocity is 0 up to half of the time. So I'm going to skip this section and I'm going straight to this one. So here, D is equal half AT squared again, but my D here is not L. I don't know which is the distance the feather would be half of the time falling. So because I don't know, I'm going to call this D and X. I don't know. Half A. Now my T is 0.5 T squared. I'm going to simplify these equations. So x is, again, I don't want to use fraction, so it'll be 0.5a, and here you'll be 0.5 square and t square. If I take those two things of this casing, they both are square, so this is square and this is square. All right, so I'm going to, again, reorganize a little bit better, because these and these, I can simplify 0.5 cube a t square, and I'm going to call this one equation 2. So when I look at equations 1 and 2, I see something they have in common. Is the a t square. So I'm going to write right here, a t square is equal to L over 0.5. Okay, and I'm going to highlight because it's an important equation. Likewise, this is a t square is equal x over 0.5 cube. Okay, so I think we are in a good path here. So if this is equal to this and this is equal to this, we can say this is equal to this. So third, let's equalize those two expressions. So L over 0.5 is equal x over 0.5 cube. Remember, what I want to find is the value of this x, where will be the feather after half of the time falling. All right, so I'm going to keep the x here, and it will be 0.5 cube L over 0.5. So then my x is 0.5 square L, right? Because cancel out. So now, because the answer showing decimals, so x is equal to, calculator time, here is 0.5 square. So this is 0.25 L. Got the answer. Is, do I have one? Yes, right here, 0.5 L. Question from May, June 2017, paper 22, question 2, A and B. A, define velocity. Is the rate of change of displacement. Question B, a ball of mass 0.45 kilos leaves the edge of a table with a horizontal velocity v, as shown in figure 2.1. The height of the table is 1.25 meters, and the ball travels a distance of 1.50 meters horizontally before hitting the floor. Air resistance is negligible, and calculate for the ball the horizontal velocity v as it leaves the table. In this type of motion, we need to look horizontal and vertical separately. Horizontally, the velocity is constant. Vertically, the velocity increases over time. So horizontally here is v, final is v because does not change. The horizontal distance here is 1.5 meter. The acceleration is 0, and it did not say anything about time. So let me repeat time here, horizontal time. So vertically, the initial velocity is 0 because vertically is seen as a free fall. Final velocity, we don't know. The height of the table is 1.25. The acceleration is 9.81 meters per second square. because is considered there is no air resistance, and the time is TV. However, those two times are the same, the horizontal and the vertical time. So to find the horizontal velocity, I do have the horizontal distance, but I do not have the time. So I'm using the values of the vertical table to calculate this time. Since they are equal, then when I have this value, I do my substitution here, and I can calculate the velocity. Okay, for the vertical table, I'm using this equation. The V is half AT squared. The VIT is 0 because my initial velocity is 0. So my dV is 1.25, and this is 4.9. A is 9.8, divided by 2 is 4.9, dV squared. So that is the square root of 1.25 over 4.9, and that's the time. Now that I have the time, I can calculate the horizontal velocity. So the dH is 1.5 divided by th, the time, which is the same, 0.5. So this is, using a calculator, is 1.5 divided by 0.5 is 3. So 3 meters per second. So that's the answer. A projectile is fired from point P with a velocity v and angle theta to the horizontal, and it lands at point Q, a horizontal distance r from P after time t. Lots of letters. The acceleration of free fall is g, air resistance is negligible. Which equation is correct? So all the equations here is showing the horizontal distance in terms of something. So we need to find what is this horizontal distance. So here is the horizontal and vertical components of this initial velocity v. So horizontally is r. So r is the horizontal velocity times the horizontal time, that will be the total time in the air. So r is VH is V cosine of theta, and TH, here the story says that the total time from P to Q is uppercase T. So we are going to replace this time here with the uppercase T. So we can rearrange this formula as VT cosine of theta. So the answer is A.